Hi, let's try a few questions on the topic of comparing coefficients. Okay, let's take a look. So I have 3 questions prepared. We'll go through them one by one. Let's start with question 1. So, question 1. Given that you have p plus 2 times square root 5 over square root 5 minus 1 plus p over 4 root 5 equals to q plus 13 over 5 times root 5, the question asks you to find the value of p and q. So here is how you deal with it. Leave the right hand side alone because there's nothing much we can do. There's a q, there's a 13 over 5 root 5, you add them together, we can't really do anything. You could make the denominators the same, but that's not very useful. Instead, you want to start with the left hand side. Okay, copy it over, right? And then you try to rationalize the denominator, because over here on the right hand side, you'll notice that the denominators are all rational. Right, rational meaning no square roots in the denominator. This square root 5 is square root 5 over 1, so this 1 is the denominator I'm referring to, and it is rational. Okay, good. So rationalize the denominator. How do we do that? When you have a root 5 minus 1, that means you have to multiply top and bottom by the conjugate surd. It looks like this. The opposite of minus becomes a plus, right? Root 5 plus 1. So what happens here is that there will be an invisible pair of brackets like this. So a minus b times a plus b. What happens to the denominator? You're left with a square root 5 square minus b square. Of course, if you want to save some time, you can calculate this at the side and straight away realize that it's just 5 minus 1, which simplifies to just a 4. So I will also do that and simplify it into a single 4. Next, we got this multiplied by that. So we're just going to distribute it straight away. P times root 5, p times 1, I end up with p times root 5 plus a p. Next, positive 2 root 5 times root 5 and then times 1, I end up with a plus 2 root 5 root 5. That gives me root 5 squared. So, right, root 5 times root 5 gives you root 5 squared. But when you take a square and a square root, they cancel each other off. You're finally left with just a 5. So 2 times 5. But 2 times 5, that just simplifies into a 10. Okay. Next, we got 2 root 5 times 1. You end up with just 2 root 5. Plus, this is p over 4 root 5. You can multiply top and bottom by just a root 5. Just a root 5. Take note, when you have a plus or minus going on in the denominator and it involves a square root, you multiply top and bottom by the conjugate surd. Whereas if you only have a single term, no plus or minus going on, just a single square root, you only need to multiply by itself, the square root 5. Don't need to plus, don't need to minus. Okay? Yeah, so simplifying that, you end up with p root 5 divided by 4 times root 5 times root 5. Let's just do a quick calculation at the side. Root 5 times root 5 gives you root 5 square, and what a coincidence. Square root and square, they cancel each other off, you're left with just a 5. So 4 times 5, you get a 20. Now, when you have a fraction plus a fraction, what do you have to do? You have to make the denominator the same. Now, before I do that, let me just clean up the numerator here. So copy and paste. Numerator clean up. So p copies of root 5 plus 2 copies of root 5. That gives me, let's see, p plus 2 copies of root 5. I am essentially factoring out the root 5. Like this. Can you see? Root 5 here, factor it out. You're left with just the p and the plus 2 in the brackets. The p plus 2 must have a pair of brackets around it. Next, you got the p plus 10. Well, we can't do anything much, so I bring the p plus 10 back. Okay, good. Then you proceed to multiply top and bottom by, in this case, 5, right? 5 to the entire numerator, 5 to the entire denominator, which is just a 4. So that you can get 4 times 5, 20. So now that the denominators are both 20, you can combine into one single fraction with the single denominator 20. Then you multiply the 5 into the square brackets. So let's just do that. 5 times of p plus 2 root 5 plus 5 times of p plus 5 times of 10. Okay, and then you plus a p root 5. Very good. Okay, anything else we can simplify? Yes, there's a root 5, so we can again factorize out the root 5. You end up with this plus this. So it's 5p plus 2 plus a p bracket times a root 5 plus 5p plus 50 all over 20. simplify this a bit more, I end up with, okay, I'll just do it at the side to save some space. 5p plus 2 plus p, this gives me 5p plus 5 times 2, 10 plus p, that gives me 6p plus 10. So replace it with 6p plus 10, root 5. With brackets around the 6p plus 10. Plus 5p plus 50 all divided by 20. Good. Now we can do a further simplification. I'm going to swap the 5p plus 50 with the 6p plus 10 root 5. So it will look something like this. Okay. Something like this. And then what I'm going to do next is I will split it up. Split it up. Those that have a square root, something times the square root, I will split it up so that it goes to the right. Likewise, for the ones that don't have square root, I will split it up and put it to the right. I am essentially splitting the fraction into two pieces. The rational part and the irrational part. It's a bit like, imagine you have 3 plus 4 over 5. It's exactly the same as 3 over 5 plus 4 over 5. The numerator can split into two numerators of two separate fractions. Right? When you add fractions, you have to combine into one single fraction with a single denominator, but now we're just working backwards. The 3 is acting like the 5p plus 50. The 4 here is acting like the 6p plus 10 root 5. 6p plus 10 root 5. Something on the left, something on the right, you split it. Okay, something on the left, something on the right, you split it. But the denominator has to go to both of them. Okay, good. Then we can do a bit more simplification. The root 5 here, we can bring it to the right side like this to make it look extra neat. Extra neat. So let me just write my fraction nicely. Like this. Good. Then, now that we have it in this form, we can compare it with the right hand side, which was a q plus 13 over 5 root 5 over here. Comparing, we end up with an equation like this. Okay, this entire expression equals to q plus 13 over 5 root 5. At this stage, I hope you can see that this part doesn't involve the square root. The q also doesn't involve a square root. Whereas this part here is sort of like a coefficient of root 5, and this part, that part there, there's a 13 over 5 in front of the root 5, which is sort of a coefficient of root 5. Then from this, we can compare yellow with yellow, blue with blue, right? So 5p plus 50 divided by 20, the rational part of this expression on the left-hand side is the same as the rational part, this guy, of the right-hand side. Okay, the yellow with the yellow equals to q. Likewise, you connect with our end. 6p plus 10 over 20 is equals to 13 over 5. Good. So from here, you can see that this guy can only has one unknown p, so we can solve for p. Right. So let's just do that. Maybe I can factor out a 2 first before I continue. This becomes 2 times 3p plus 5 over 20. Cancel off the 2. I'm left with 10 on the top. Sorry, 10 at the bottom, 1 at the top, equals 13 over 5. Let's just clean it up so it now looks like 10 here, 1 times here. Of course, 1 times you don't have to write it anymore, so it's just 3p plus 5. Clean it up a bit more. It's 3p plus 5 over 10 equals 13 over 5. Cross multiply now. So 5 bracket 3p plus 5 equals to 13 times 10. Okay, times. Simplify, you get 15p plus 5 times 5, 25 equals to 130. That means 15p equals to 130 minus 25. This gives you 105. 15p on the left. To solve for p, you just divide over. This should give you, let me see, I think it was a 7. I checked it before. And yes, I get a 7. Good. Now that we have p equals to 7, we look back at this other equation. Oh, what a coincidence. There's a p here. We can replace the p with a 7. Right. If you started off with this equation, you will get stuck because there are 2 unknowns here. You cannot solve for any of the unknowns. You can only have one unknown letter in the equation. In this case, on the right side, we only had a single p. That's why we could solve for p. Here there are both p's and q's. We can't solve for anything until we figure out that p is 7 and replace it. So what we end up with is 5 times 7 plus 50 over 20 equals to q. Type in a calculator, what do you get? 35 plus 50 over 20, that's 85 over 20. Actually, I could have just typed the whole thing in a calculator straight away. I end up with 17 over 4, and that's your answer. Okay, this is comparing coefficients with surds. Okay, rational part with rational part, yellow with yellow. Coefficient of the irrational part, coefficient of the irrational part, blue with blue. Okay, good. Now let's move on to question 2. How do we deal with this one? This involves function notation, in particular composite functions. So let me show you how to do it. We start off with a f of x equals to 3x plus c, and you have another function g of x is cx plus 7, and they tell you that f of g of x, okay, they may also write it as simply fg bracket x, like this, also a possible notation. They tell you that this composite function is 21x plus 28. Then you want to find the value of c and d. How would you do that? First thing, you must understand how do you obtain a composite function, f of g of x. F of g of x. This is the outer function f, that is the inner function f. That's how you read it. Okay, the brackets, the function that is outer is written first, then you put a pair of brackets, and inside the pair of brackets you put an inner function g. Okay, just like Russian doors, like you have a door, and then you have another door inside of a door, and another door inside the door inside the door. Okay, so something like that. But how do you do it mathematically? What you do is you write down f of g of x. Then think about it. What is f of something? It's really just this function here, right? So it's 3x plus c. So let's copy that down, 3x plus c. But I purposely left a blank there because is it actually an x? No, it's actually now, the f of x is now actually replaced with f of g of x. Sorry, I mean the x within the f of x is replaced with a g of x. Let me just highlight it in yellow. X here, g of x there. It got replaced with a g of x. So that means that everywhere where there was previously an x, over here, we're going to replace it with a blank space like this, and then we've replaced that blank space with the corresponding expression in between the brackets, which in this case is g of x. We're going to replace the blank with a g of x. But what's g of x? Oh, it's right over there. There. So we're going to fill in the blank with g of x. Okay, so cx plus 7. Now we got an expression, we can expand it. When you have brackets, you multiply it, right? So 3 times cx, 3cx, 3 times 7, 21, plus c. Good. So what you notice is that this part here is the coefficient of x. That part there is the constants. This is the coefficient of x. And then you can do comparing coefficients. So this is exactly equals to f of g of x, but we already know that f of g of x is what? It's 21x plus 28. It was given. So we just have to copy it down, 21x plus 28. And then you compare. Okay, so coefficient of x with coefficient of x, constants with the constants. Let me just use a pink color here, pink color there, and the constants with a stapler bullet looking thing to identify the correct part of the expression we should be looking at. So pink with pink, in particular the coefficient in front of the x. Okay, so that means if you stare at the pink, by comparing coefficients, you can write that down if you want to. By comparing coefficients, this implies that 3c equals to 21, right? Pink with the pink. Then from there, can you solve for c? Yes, 21 over 3, you get 7. Okay, c equals to 7. Not enough, we still need to continue. Okay, actually we don't need to. We could have also compared 21 plus c with the 28, and solving, actually it's a lot simpler. 28 minus 21, we end up with a 7. That also gives us c equals to 7. So either one is fine. Either one is fine. Comparing coefficients of x like this, or you compare the constants like that. Both will give you the same result. Okay, then finally, let's look at question 3, which is a vector question. Now this question has many different, you can have many different ways to approach it, but let me show you the equating coefficient method. Okay, so the trick here to solve this question, okay, let's read the question first. PQRS is a parallelogram. M is the midpoint of SR, right? So it's in the middle. PS is produced to T, meaning you take PS and then you extend it with a ruler going in the same direction. So this is one straight line produced to T so that PS equals to ST. So these two lengths here and there are equal. We represent that with a tick mark like that. PM is produced to N. So where is PM? Over here. Where is N? It's over there. What does it mean when we say produce to? It means we extend it with a ruler. So PMN are collinear, one straight line. So that RT equals to 3RN. So what does that mean? So let's just draw a quick diagram. RT equals 3RN. So if you look at the diagram, the RN and T, maybe I'll label it like this, R, N, and T, they tell us that RT equals to 3RN. So let's just write it down. RT equals 3RN. So we can bring that Rn over to the other side to make it look like a fraction. So RT over Rn equals to 3, which is the same as 3 over 1. Let's just simplify it and write it straight away as 3 over 1. What does that mean? Okay, what does that mean? It means that we can now label the diagram over here. It's essentially this line here, but I rearranged it. Okay, would it make more sense if would it be a bit more intuitive if I just write it like this? T, then N, then R. Maybe it's easier to visualize. Okay, I think it might be better. So let's see. RT to Rn, 3:1 ratio, right? That's how you read a fraction. It's this fraction is equivalent to a ratio. RT to Rn equals to 3:1. Okay, so let's label this diagram. So over here, with a fancy curvy bracket, RT is 3 units, right? So draw a circle like this. Then Rn is 1 unit. So over here it's 1. So what do you think is the number of units for Tn? Total is 3. Here it's 1. Of course it must be 3 minus 1. You end up with 2 units. Okay, good. So that's the information we can deduce from this line here. There's a ratio 1:2:3. Good. So PQ equals to 2A, labeled already on the diagram. Vector 2A, 2 times of vector A. QR is 2B, so it's 2 times of vector B. And the question tells you that the ratio of PM is to MN equals to N is to 1. So that means that you have a PM here, you have a MN there, the ratio is N is to 1. Question, find the value of N. So in this case, there are many different ways to approach this question, but let me show you one such way. So our strategy here is going to be equating coefficients. The last final step that I want to write down is eventually going to be PM equals to PM. What? Why are you telling me such an obvious thing? PM equals to PM. Of course they are equal. What do you mean? What I mean is there is a clever, of course, I don't just want to write down PM equal to PM for fun. What we want to do here is to rewrite the PM in 2 different ways and use that to help us to solve the question. Okay, so let's take a look. PM here, do you agree that it's actually just a scalar multiple of this Pn, right? It's just a shorter version, right? Right, so that means that we can actually say that PM is some ratio times of vector Pn, right? Because it's just a parallel vector. It's a parallel vector, so it's a scalar multiple, some scalar multiple in front. But can you figure out what that scalar multiple is? Yes, you can. Why? Because they told you a ratio here. PM to Mn. Let me just draw a line to separate the working. PM to Mn equals to N is to 1. So what does it mean about PM to Mn as a fraction? It's really just N is to... Sorry, PM to Pn. Sorry, I meant Pn here. Maybe it would be easier if we just draw a diagram and label it like this. So you draw a short line like this. Here is P, here is M, here is N. They tell us the ratio is N is to 1, right? So what's the total length of Pn in terms of units? It will actually be n plus 1 units, right? Ah, okay, good. So what does it mean about Pm to Pn now? Pm, n units. That's why I wrote an n there. Pn, the total length here, n plus 1 units. So n over n plus 1, right? So what we have essentially done is to express Pm as a fraction of Pn. P monkey as a fraction of P, what's a good word for n? No. Nope. P nope. Okay. Pm is n over n plus 1 of Pn. So that means that will be our scalar multiple. N over n plus 1. Right? That's one way to express the vector Pm. Right? What's another way? We can also express vector Pm as, let's say, for example, Ps plus Sm, right? Using triangle law. You just have to make sure that the S and S is connected, right? P travel to a middle of nowhere S, and then S from the middle of nowhere you travel back to the final destination endpoint M, right? P to S, S to M. Add them together, you end up with Pm. Okay, good. With that, we are almost able to solve for n already. Now we just need to figure out what's Pn, Ps, and Sm. Ps is very simple. Take a look at this diagram. It's a parallelogram, so opposite sides are equal and parallel. So that means that Ps is actually exactly the same as Qr, right? And also notice the direction of this arrow. Qr is vector 2b. So that means that Ps, the same direction, will also be 2b. Okay, so that means over here, Ps, I will have a 2b. Because Ps will also be vector 2b. Maybe I should write a short note here. Ps exactly equal to Qr, which is in turn equals to vector 2b. How about Sm? So Sm here, because M is a midpoint of the SR, that means that Sm is actually, okay, maybe I should write the working somewhere else. I should write it over here at the side. Sm will be half of SR. Can you see that? Right, because M is a midpoint, so Sm is just half of the SR. But wait, what's SR? Again, because of parallelograms, we know that opposite sides are equal. In particular, SR is equal to PQ in terms of its length, and they have the same, they are pointing in the same direction. They are parallel to each other. That means that SR will be equals to PQ. Right? So that means that SR can be replaced with vector PQ, provided that they are pointing in the same direction. S towards R from left towards right, P towards Q from left towards right. Okay, and just nice, coincidentally, PQ, vector PQ is vector 2a. So we can just replace it with half times of 2a. Half times 2 cancel off, you're left with just a vector a. Very good. So that means that Sm equals to vector a. I can replace the Sm over here with vector a. So plus vector a. Very good. Now, the challenge. You have a n over n plus 1 on the left hand side, but you have a Pn. How can we express this Pn? How can we possibly find out what's Pn? This requires a bit more work. So there are many ways to approach this, but one such way that I found to find the vector Pn is go from P to T first, and then T towards N. Okay? So let's find out what's that. Vector, so Pn, we know that it will be eventually Pt plus Tn. Maybe I shouldn't have written it down. I should write the working down over there. Oops, not enough space. Let me just adjust my brackets. Okay, good. Like this, Pt plus Tn. So now the problem simplifies down into finding out what's vector Pt, finding out what's vector Tn, add them together, right? So let's do that. So let's remove this. How do I find out what is vector Pt? Very simple, because they told us that Ps equals to St, right? It was given. That means that all we need to do is to double the vector Ps. And we already found out what's vector Ps, right? It was 2b, right? Remember? Ps equal to 2b. So we just have to double it, because there's a 1-to-1 ratio. So that means this entire length will be 2 units. Double that of the first 1 unit. So that means we can just double the vector Ps, which is double of vector 2b, which is then 4b. Very good. We have our expression for Pt done. We found our vector expression for Pt, which is a 4b. Okay. How about Tn? So Tn, this one is a little bit more challenging because we need to think a little bit more. Remember how we figured out this information here with Tn, Nr, and Tr having a 2 to 1 to 3 ratio. Yeah, we're gonna make use of that. So in this case, do you agree that Tn is actually just a shorter version of Tr? Yes, right? Okay, so that means that we can have vector Tn to be some scalar multiple of Tr. They are parallel vectors. But in particular, if you pay attention to this diagram here, Tn is worth 2 units, the entire length Tr is worth 3 units. So that really means that it's just 2/3 of Tr. Right? Very good. So now our job is to figure out what's Tr. Can we find out what's Tr? Yes, let's think about it. So for vector Tr, you will need to always remember the triangle rule. Okay. In particular, Tr here, you can rewrite it as, you have to be a bit creative here, and look at the diagram, and you realize that, hey, to travel from point T towards R, you could first travel from T towards S, then from S towards R. In other words, Ts plus Sr. Right? But now if you pay attention to Ts, you realize that, hey, it's really just the same length as this Ps, it's just pointing in an opposite direction. So what does it mean if it's an opposite direction? Instead of a positive 2b, it will now be negative 2b. So that means that your vector Ts here will be negative 2b with the 2/3 with the bracket. How about Sr? So Sr over here, we already found it previously, right? It was really just PQ. Sr is the same as PQ, right? Because opposite sides of a parallelogram are equal and they are pointing in the same direction. So I can just use PQ, vector 2a. So plus 2a. Very good. Now I can factor out a 2, so I get a 4/3 and a minus b plus a. Okay, good. Now I have my expression Tn in terms of a and b. I can now substitute it back into this final expression, right? Let me just shrink it down to save some space, and don't forget the plus 4b and the brackets. Adjust a bit, make it look nice. Equals to 2b plus a equals to 2b plus a. Very good. Now we have an expression in terms of a, b, vector b, and n over n plus 1. What do we do now? We just simplify. So I am not going to multiply n over n plus 1 yet. I'm going to simplify the following expression. So 4b plus 4/3 times negative b is negative 4/3 b, and then 4/3 times positive a gives you 4/3 vector a equals to 2b plus a. Very good. So now 4 minus 4/3, what does that give me? Let's just leave the answer as an improper fraction. I see that the answer is 8/3. 8/3 vector b plus a 4/3 a. Don't forget the n over n plus 1 in front. Equals to 2b plus a. Okay, with that, we can start to expand the brackets by multiplying n over n plus 1 inside. So just leave the n over n plus 1 alone. Then you multiply it by your 8/3. Don't forget the vector b. Plus n over n plus 1, leave it alone, times the 4/3 a. Right? Equals to 2b plus a. Now we have something very interesting. Vector b, a coefficient in front. Vector a, invisible coefficient 1 here. This part and this part. Then we can just compare coefficients. By comparing coefficients, we realize that the red part here, n over n plus 1 times 8/3, equals to 2. Right, from there we can solve for n actually. We don't even need to compare the pink color part, but you can if you want to. Okay, n over n plus 1 times 4/3 equals to 1. They are exactly the same. Can you see that you just have to divide by 2 to get to the other guy? Yeah, so let's just, okay, you know what? Let's just work with this guy because it's simplified already, divided by 2. So you can try this on your own. I mean, it's really just dividing by 2, so it's equivalent. So let's just work with this one by comparing the pink color coefficients. Oops, this part here with that part there. Okay, and let's just simplify this a little bit. The times 4/3, I'll bring it over. It becomes times 3/4, right? Times 4/3, bring over becomes divide by 4/3. Keep change flip, you get times 3/4 instead. 1 times 3/4 is just 3/4. Okay, then you cross multiply. So 4n equals to 3 times n plus 1. Multiply out, you get 3n plus 3. Bring the 3n over. You're left with a 3, and therefore finally n equals to 3. Done. Okay, that's it.